Have you ever looked up at the sky, seen a plane soaring overhead, and wondered, how on earth does that massive metal bird actually fly? It seems to defy gravity, but it's not magic, it's a symphony of brilliant engineering. Today, we're going to pull back the curtain and explore the three essential elements that work together to make flight possible. So, buckle up, because we're about to take off on a journey into the heart of an airplane. First up, let's talk about the body of the plane, what's known as the airframe. Think of it as the aircraft skeleton and skin all in one. The airframe is the entire physical structure. You see the long tube-like body, the majestic wings, the tail at the back, and the wheels it stands on. Its main job is to be incredibly strong yet surprisingly lightweight. It has to hold everything together, from the passengers and cargo to the fuel and engines, all while withstanding the immense forces of flight. The central part of the airframe is the fuselage. This is where the crew, passengers, and cargo are housed. It's essentially the main body of the aircraft, connecting all the other parts. Then you have the wings, which are the real superstars of flight. They aren't just flat planks sticking out the sides, they're masterpieces of aerodynamic design. Their curved upper surface and flatter lower surface create a pressure difference as air flows over them, which generates the upward force we call lift. Without lift, a plane is just a very expensive bus. At the very back of the plane is the empennage, or what most of us just call the tail section. This part is crucial for stability and control. It acts much like the feathers on an arrow, keeping the aircraft flying straight and preventing it from tumbling through the air. The empennage consists of a vertical fin and a horizontal stabilizer, which have movable surfaces that allow the pilot to steer the plane up, down, left, and right. And finally, you have the landing gear. Its job is pretty self-explanatory. It supports the aircraft on the ground, allows it to taxi to and from the runway, and absorbs the massive impact of landing. Now, building an airframe is a delicate balancing act. You need materials that are strong enough to handle extreme stress, but light enough to not weigh the plane down. This is why aerospace engineers use advanced materials like aluminum alloys, super strong composites, and even titanium in critical areas. It's all about maximizing strength while minimizing weight to achieve the best possible performance and fuel efficiency. So, the airframe provides the shape, the strength, and the space. But it can't go anywhere on its own. For that, it needs power. And that brings us to the second essential element, the engine, or the power plant. The engine is the heart of the aircraft, providing the raw power needed to get off the ground and push through the air. Its job is to convert fuel into a powerful force called thrust. Think of thrust as the force that propels the plane forward, constantly fighting against air resistance, or drag. There are a few different types of engines you'll find on planes. Smaller, propeller-driven aircraft often use piston engines, which are quite similar to the engine in your car. They use pistons moving up and down to turn a crankshaft, which in turn spins the propeller. The propeller's blades are shaped like mini wings, and as they spin, they bite into the air, pulling the aircraft forward. But when you look at a modern airliner, you'll see large, round engines without propellers on the outside. These are turbine engines, and they are the workhorses of commercial aviation. The most common type is the turbofan. A turbofan engine works by sucking in a massive amount of air through a large fan at the front. A portion of this air goes into the engine's core, where it's compressed, mixed with fuel, and ignited. This creates a high-velocity jet of hot gas that shoots out the back, generating powerful thrust. The rest of the air bypasses the core and is simply accelerated by the fan, producing additional thrust. This bypass system makes turbofans much more fuel efficient and quieter than older pure jet engines. The engine isn't just for moving forward, though. It's a critical component in every phase of flight. It provides maximum power for the demanding takeoff and initial climb. Once at cruising altitude, the pilot throttles back to maintain a steady speed, conserving fuel. And even during descent and landing, the engines are ready to provide thrust if needed. On top of that, the engines are often a source of power for other vital systems on the aircraft, which brings us to our third and final element. So we have the structure from the airframe and the power from the engine. But how does a pilot actually control this complex machine and ensure everything runs smoothly? That's where the aircraft systems come in. These are the intricate networks, the brains and nervous system of the plane, that manage everything from steering to keeping the cabin comfortable. First and foremost is the flight control system. This is what allows the pilot to maneuver the aircraft. When the pilot moves the control yoke or stick, it sends signals to movable surfaces on the wings and tail called ailerons, elevators, and the rudder. These surfaces deflect into the airflow, changing the aerodynamic forces on the plane and causing it to pitch up or down, roll left or right, or yaw side to side. In modern aircraft, these controls are often electronic, a system called fly-by-wire, where computers interpret the pilot's inputs and make precise adjustments. Then you have the fuel system. It's not just a simple tank. It's a complex network of tanks, pumps, and valves that store fuel, usually in the wings, and reliably deliver it to the engines. No matter the aircraft's orientation, the electrical system is another one, acting as the aircraft's power grid. It generates electricity to power everything from the cockpit displays and navigation computers to the cabin lights and coffee makers. For moving heavy components like the landing gear, flaps, and brakes, planes rely on hydraulic and pneumatic systems. These use pressurized fluid or air to generate immense force, allowing a pilot to operate these large parts with minimal effort. You also have the environmental system, which is crucial for survival at high altitudes. It pressurizes the cabin to a comfortable, breathable level and controls the temperature, so you're not freezing in the -50-degree air outside. And finally, we have the avionics. This is the suite of advanced electronics in the cockpit. It includes the communication radios to talk to air traffic control, navigation systems like GPS to know exactly where the plane is, and a whole host of screens and instruments that monitor the health of the aircraft in real time. The avionics are the pilot's eyes and ears, providing all the information needed to fly safely and efficiently. So there you have it. Flight is an incredible collaboration between these three core elements. The airframe provides the strong, aerodynamic structure. The engine delivers the massive thrust needed to conquer gravity and drag. And the aircraft systems provide the control, safety, and functionality that tie it all together. Each part is useless without the others, but when they work in perfect harmony, they create a machine that can safely and reliably carry hundreds of people across continents. It's a testament to human ingenuity and a beautiful example of engineering in motion. Next time you're on a flight, as you feel that powerful push during takeoff, you'll know exactly what's happening. It's the engine roaring to life, the wings slicing through the air to generate lift, and 1,000 different systems working flawlessly behind the scenes. Thanks for watching, and if you enjoyed this deep dive into the world of aviation, don't forget to like, subscribe, and hit that notification bell for more. Fly safe.